So in this video we are going to solve this CAD test. So here you can see this is a dump to para CAD test. So we have to find the tooling direction and we can extract the A surface in this CAD test. So we have the dump solid part you can see, and we have to create the same part, but that part should be parametric. Okay, so here we can extract the A surface and we have to find the tooling direction. Okay, so first I will create one feature group for the main tooling direction. So we have this screw boss feature is given, so with the help of that we can find the tooling direction. So I will create one center point, and so basically I will create two center points and I will create a line passing through these 2 points. Or I can create one line like this using this B-side feature. So this will be the main tooling direction. Okay, so what I will do, I will extract the A surface first. Okay, so I'm going to extract the A surface. So in the PPT itself it is given that we can extract the A surface, and after that we have to just follow our A to B surface methodology to create the base part, to create the closed volume of this base part. So I'm just extracting the A surface. So I will just simply create one feature group for the A surface, and now you can see we have the A surface only. Okay, so now we have the A surface and main tooling direction, and what I will do, I will first join all the surfaces. And now I'm just going to perform a draft analysis. I'm going to examine the geometry. If there is any issue, we have to check it. So here you can see there is this gap is there. This surface is not perfect, so we need to modify that surface. So I have just deleted the sieve command, and what I'm going to do is I'm going to create a new surface here. So I will create one curve, or I can say isoparametric curve like this, so that I can trim the surface, and in between this we can create a new surface by using through curve mesh command, by giving the proper continuity. Okay, so let's okay, so that is creating some error. So what I will do, I will create isoparametric curve on this surface, and I will trim this now. Okay, so now let's see if we can create a surface by using through curve mesh command now. So you have to properly select the boundaries. So here I have extended this surface a little bit by 0.1 mm, and now let's try to create the surface. Let's apply the continuities properly. Okay, so now this is the surface is created, and now we need to join this, and then we have to check it if it is okay or not. Okay, so let's join this, and let's examine the geometry again. Okay, so now that on that area the boundary is not showing, which means now the A surface is correct and there is no issue on this A surface. So this will be the final A surface, and using this A surface we are going to create the B surface now. Okay, so I will insert one feature group for the B surface. Okay, so we have to see what is the thickness in this dump solid. So we have to check the thickness first. So the thickness is 3 mm, as you can see. So the thickness is 3 mm. Okay, so the thickness is 3 mm, so we have to just offset this by 3 mm. Okay, so we have to offset this vertical surface now. Okay, so now let's offset this surface. So now this is done. As you can see, the base surface we have created, and now we just have to extend this surface so that it properly intersects with the bottom surface so that we can trim it properly. So we have to just extend these two surfaces, and then we have to just trim it. Okay, so now this is done. Okay, so now we have to create the closing surface. So we have to just close the A surface and B surface. Okay, so let's apply the angle. So we have to check the direction. Okay, so now this is fine. So we have to just extend this. So I will increase the length of this surface so that it properly intersects with the B surface, and now we can trim these two surfaces. Okay, so now we have created the A surface, B surface, and closing. So now we can finally join all the surfaces so that it becomes a solid body. So here you can see there is this boundary appearing. So what I will do, I will create a composite curves here, and I will just trim this. Okay, so now here I can create a new surface by using through curve mesh. Like this. Okay, so now let's join this again. And okay, so now if you take a section cut, then you can see it has become a solid part. And if you turn the old part, then you can see this part is perfectly matching with the old part. Okay, so now we will do the next step. So the base part we have created, and now here we need to create these features, the beside features we need to create. So here I'm just creating one axis system. Okay, so here we have created one axis. Okay, so here we have to just measure the radius or the diameter of these circles, and according to that we have to create a circle of the same diameter. Okay, so I'm just extruding this profile like this. Okay, so now here we need to apply the draft, then it will perfectly match with the old part. So we need to measure the angle. So there is a 0.5 degree draft is there, which we have to apply. So let's just apply the draft now on the vertical face. Like this. So now you can see we need to create this portion now, which has 1.75 radius. So this slot we have to create. So again we have to create the sketch, and we have to create a circle, and we have to just remove it from this body. So we can only take a reference of the old part, which is the dump part, just to take measurements from it, and so that we can create a parametric model. So there should not be any link between the dump part and the part you are going to work right now. So there should not be any link. So when you so if you delete the dump part, then your part should be there as it is. There should not be any link between these two parts. So even if you delete the dump part, your part has to be present. And if you want to modify anything in this, then you should be able to modify it. So that is what is meant by parametric modeling. So you should be able to modify it in future if there is any requirement like that. Okay, so let's create a circle here. Okay, so now you can see now this body is perfectly matching with the old part, as you can see. So this is the visual method to check if this is matching or not. Otherwise you can also compare these two parts, but we can compare these two parts visually only, so there is no requirement. So visually we have to compare it. So now these four gussets or ribs we have to create now. We have to create the gussets and the ribs. Okay, so for that we have to create a sketch on this plane. And we have to just create 4 lines from the center. You have to just create the horizontal and vertical lines like this, and then after that we will simply apply the thickness to these profiles, and then it will be done. So now we have to define their length, so we have to measure it from this dump part. We have to measure the length. So this is 6.97, which means it is almost 7 mm, and this is 9.01, or which means it is 9 mm. Okay, so here we have created this profile, and we need to measure the thickness of this first. Okay, so it should be -5, okay, 0.5. Okay, so now this is okay. So similarly I will extrude this profile also. Okay, so we have to measure the thickness of this. So it is 1.25. Okay, so we have added the thickness. So similarly we have to do the same thing for the remaining 2 gussets. Okay, so we have to measure this distance. Okay, so we have created this feature and now we have to just apply the draft. We have to apply draft angles on the vertical faces. Okay, so let's hide. So as you can see, now this is matching with the old body. So now we have to measure this distance. So we have to remove that material from there. Okay, so I'm going to create a sketch.